Hello there, it's Felicitas Chenge here. We want to solve the inequality. The modulus of 2 to the power x minus 20 is less than or equal to 12. I once did this solution. I once solved this inequality, but using the table of signs. So you can check out my previous video. I did this inequality. I solved this inequality using the table of signs. You can check on my previous video. Right, to solve this inequality using the graphical method. Today we want to use the graphical method. Right, by using the graphical method, we want to sketch this graph, and we sketch the graph of y is equal to this and the graph of y is equal to 12. After sketching the two graphs, we want to find when this graph is less than or equal to this graph. So to sketch this graph, right, first of all we sketch the graph of y is equal to 2 to the power x minus 20. Before the modulus there, we sketch the graph of y is equal to 2 to the power x minus 20. We want to see the nature of the graph. Right, remember the graph of y is equal to 2 to the power x minus 20 belongs to the exponential family. Right, so the graph of an exponential graph is, let me draw our exponential graph, is in asymptote there. Right, it is an asymptote at x is equal to 0, and it passes through 0, 1. So that's the graph of y is equal to e to the power x. That's our exponential graph. So with that in mind, we are going to sketch this graph. So this graph, the graph cuts the x-axis when y is equal to 0. So we are going to substitute y with 0 there. So 0 is equal to 2 to the power x minus 20. Right, this comes this side, we have 20 is equal to 2 to the power x. Then introducing ln both sides, we are going to have ln 20 being equal to ln 2 to the power x, and ln 20 is equal to x ln 2. So to remain with x this side, we are going to divide both sides by ln 2 by ln 2. Right, so we now have x being equal to ln 20 divided by ln 2 is equal to 4,32. So it's 4,3. So our x is going to be equal to 4,3. So the graph cuts the x-axis at 4,30. Right, that's our first intercept there. Then another intercept, we want to see where the graph cuts the y-axis. So the graph cuts the y-axis when x is equal to 0. So when x is equal to 0, we are going to have y being equal to 2 to the power 0 minus 20. So the graph cuts the y-axis when this becomes 1 minus 20. So our y is equal to negative 19. So when x is 0, y is equal to negative 19. Right. This is just by transformation, this is just a shift from there to negative 19. We have moved 20 units down the y-axis, so it's going to be like this, right? So those are our intercepts. The graph cuts the x-axis at 4,30, and it cuts the y-axis at 0, negative 19. Right. So our graph will be like this. So this is the graph of, this is the y-axis and this is the x-axis. So at 4,3, 0 and 0, let's say our negative 19 is there, negative 19. Then it will have an asymptote at, right, the graph is undefined when x is negative 20. We've just shifted this graph by 20 units from there to there. So it had an asymptote there, it's going to have an asymptote at negative 20. Right, to verify that when y is equal to negative 20, we are going to have negative 20 being equal to 2 to the power x minus 20. This comes this side, we are going to have negative 20 plus 20 is equal to 2 to the power x. So 0 is equal to 2 to the power x. If we introduce logarithms, natural logarithms, we are going to have ln 0 being equal to ln 2 to the power x. Ln 0 is undefined, so the graph is undefined when y is equal to negative 20. So we are going to have an asymptote there. We are going to have an asymptote there. So our graph is going to be like this. It's just a sketch. Bear with me, it's just a sketch. Right. That's the graph of y is equal to 2 to the power x minus 20. Right, but remember we want the modulus. So for the modulus, the graph is not going to from there to there, it's not going to pass this x-axis going downwards. The modulus is going to reflect this part upwards, right? So we are going to have our graph doesn't have negative y values. So we are going to have our graph like so. So this is the x-axis, this is the y-axis, right? It's going to be like this. It comes here at 4,3. This is 0.4,3 there. And since it was passing through this point negative 19, so this negative 19 is going to be reflected onto the positive side, so it becomes 19 there. And our 20 is going to be the asymptote there. This is 20, right? So our graph will be like so, right? That's the graph. It was going this, right? So our graph is going to be reflected onto the positive part. But remember, we want to solve the graph of modulus of 2 to the power x minus 20 is less than or equal to 12. Right, so we need to draw the graph of, let me quickly draw a diagram that is neat down here. A neat diagram. This is our x and this is our y. Right, so we are going to have the graph coming to 4,3 there, and it's being reflected upwards up until 19 there. So this graph is going to be, let's say this is our 20, this is our asymptote, right? Set y is equal to 20 there, right? So that's our graph. Y is equal to modulus of 2 to the power x minus 20, right? Then we want to draw the graph of y is equal to 12. So the graph of y is equal to, let's assume our 12 is here. So the graph of y is equal to 12. Right, this is y is equal to 12. So we want to find the coordinates of this point and this point, the coordinates there, right? So the value of x, we can find the value of x by equating this to this. So when these two graphs are equal, we are going to obtain the x value there. So when 2 to the power x minus, this is the positive part of the graph, of this graph. When 2 to the power x minus 20 is equal to 12, we are going to get 2 to the power x being equal to 12. This comes this side plus 20, so 2 to the power x is equal to 32, and 2 to the power x is equal to 2 to the power 5. So x is equal to the bases are equal, so x is equal to 5. Right, so this point is point 5, 12. And this point, this is when our graph, we find this point when our graph was below the x-axis there. When our graph was below, was on the negative side, this should have been negative 12. So when this graph intersects with negative 12, that's when we are going to find our coordinate there. So 2 to the power of x minus 20 should be equal to negative 12 to find the solution of to find the point, the coordinate of this point, right? So 2 to the power of x is equal to negative 12 plus 20. So 2 to the power of x is equal to 20 minus 12 is 8. 2 to the power of x is equal to 2 to the power of 3. So x is equal to 3. This basis, the bases are equal, so x is equal to 3. So this point is 3, 12. Right, it's 3 there, it's 5 there. Right, so remember we want to solve the inequality 2 to the modulus of 2 to the power of x minus 20. Right, remember this graph first. Right, the magnitude of the modulus of 2 to the power of x minus 20 less than or equal to 12. This graph is less than this graph from this point up to this point. So our graph of y is equal to modulus of what is below this graph from this point to this point. That's when we have this graph being less than the graph of y is equal to 12. So the solution there will be 3 is less than or equal to x less than or equal to 5. So 3 is less than or equal to x less than or equal to 5. That's when our this origin there is below y is equal to 12. So our graph is below y is below y is equal to 12 from this part to this part. So our solution is 3 is less than or equal to x and x is less than or equal to 5. So thank you.